what we're going to be covering today is called exponential functions and what they look like on the graph and what makes them shift around and things like that. The first two problems in this homework assignment are just kind of random, and we're going to be using them actually more next week. And it has to do with the letter E that we use in math. And this letter E is an irrational number, kind of like pi. And it has to do, a lot of times people use it in finance and things like that, about with investing money and how often your money is reinvested and things like that. We're going to be working more problems using the E next week, but just to see what it looks like on your calculator, the first problem says to find e to the 6th power. There's actually an E button on your calculator. If you go to your calculator, this button right here, this LN button, if you'll notice right above it, it says has a little bitty e to the x power. That's what you want. So remember, if it's blue, if it's in that up right above the button, you need to hit your second button first and then e to the x. And look, that e that it puts on your calculator, it automatically puts your cursor up in the exponent. So you'll just type in 6, hit enter, and it gives you this long number, and it says to round it to the 4th decimal spot. So after the decimal, look, 1, 2, 3, 4. And then after that, remember, if the number after the 7 is a 5 or higher, then I'm going to need to round it up to an 8. So after the 7 is a 9, which means I need to round this number up to 8. So 403.4288 is what your answer would be. Okay, now the second question is e to the negative 3.45. So same thing, I'm just going to go to the e on my calculator. So second e, and I'll put in negative 3.45. It's just as simple as going to your calculator and putting it in and hitting enter and then rounding it to 4 decimal spots. So again, after the decimal, I'll go 4 spots. If I go 1 more spot after that, since that's a 4, that means I don't need to round up that 7. So I just have 0.0317. Okay, so those are the first 2 questions. Now, getting into the main part of what this section is. It's an exponential function and what it looks like on the graph. Now, you've heard of people say, you know, somebody's growing exponentially. What that means is it's growing really fast, okay? So let's look at why that occurs. Let's sketch out what one of these exponential graphs would look like, okay? Like number 3, if you have a graph that says y equals 2 to the x power. So this is something we haven't seen before when we're graphing, is when our x is in the exponent. So let's just go ahead and make our own little XY chart like we did back in the old days before we went to the y equals all the time. And let's just put in a few numbers for this x. Let's start off with negative 2, negative 1, 0, 1, 2, and 3. So let's put those numbers in our exponent and see what that makes. So let's see, negative 2 in for this x. So if I put that in my calculator and put in 2 up into the exponent, negative 2, here I'll show you what I'm doing. So I'll put the 2 in for the base and then put negative 2 in my exponent. Let's see what that gives me. Gives me 0.25. And I'm just going to go ahead and keep that as a decimal because I'm going to graph it here in a minute. And I like to see decimals when I'm graphing better anyway. So if I put in negative 1 for the exponent, so 2, go up into your exponent, negative 1, that gives you 0.5. What do you get if you put 0 in this exponent? 2 to the 0 power Anything to the 0 power is equal to 1. Let's think about this. 2 to the first power. 2 to the first power is 2. 2 to the second power is 4. If I put the 3 in the exponent, I'll have 2 to the third power, which is 8. Let's plot these points. Okay, so the first point, if my x is -2, my y is 0.25. So that means go to the left 2 and then go up just a little bit. Then there's a point at -1.5. So to the left 1 and then up just a little bit more to a half. There's a point at 0, 1. So I don't go left or right at all. And then I go up 1 for the y-intercept, right? Because if my x is 0, this number is my y-intercept. There's a point at 1, 2. So to the right 1, up 2. To the right 2, up 4. And then to the right 3, up 8. So to the right 3, all the way up to 8. So you see what's happening when I connect these points. Look what happens on this side of the graph. What does that do? It's growing exponentially. It's starting to get big really fast. Okay? So this is what the graph of an exponential function looks like. So you will be able to choose that out of your multiple choice, the A, B, C, or D. There's going to be one that has the shape of an exponential graph. Okay. The others will have like a line. One's a parabola. You know it's not x squared, so it's not a parabola. So you'll be able to choose that exponential graph. Okay. So that'll happen on 3 and 4. So remember what the shape of this one looks like. Because now, what's going to happen to this graph, and I'll explain why, when this number, your base number, is a fraction that is less than 1. Its absolute value is less than 1. So let's see what this looks like on a problem like number 5, where the function is y equals 1/3 to the x power. So again, keep this one in mind. So I have y equals 1/3 to the x power. So again, I'm going to make my little chart, just like old school, like we did before, before we went to the, and you can make this chart in your calculator, right? By going to your y equals and then just hitting second table. It's going to do the same thing that we're about to do. I just like to see this one and plot these points out to see why the graphs are doing what they're doing. So let's start off with the same numbers, -2, -1, 0, 1, and 2. So let's go to the 1/3 to the x power. So let's see if I type that in my calculator. So open parentheses, 1/3. So just type in 1/3. Now, what do I want my exponent to be? So I'm going to go up into my exponent and then hit -2. It gives me 9. My exponent is -1. So again, open parentheses, 1/3. This time my exponent is -1. Gives me 3. What's this one going to be again? If my x is 0, what is anything 1/3 to the 0 power is still 1. Anything to the 0 power is equal to 1. Now, if I put in 1, what is 1/3 to the first power? Well, that's just going to be 1/3. And if you did that in your calculator, it's just going to tell you 0.3333. 1/3, if I put the 2 in here, 1/3 to the second power is 1/9, and your calculator is just going to tell you 0.1111. So let's see what this looks like. Remember what the last one looked like? It looked like this. It started going up when it got to the other side of the y-axis. Let's look at what this one does. Okay, so when I have -2 for the x, my y is 9. So left 2, up 9. Left 1, up 3. Left 1, up to the 3. 0, 1. So I don't go left and right at all. My y-axis or my y-intercept is +1 again, just like on the last one. Now when I go to the other side, I go to the right 1 and up a third. When I go to the right 2, I barely go up at all. So you see what's happening is it's getting really close to this x-axis. Here's the thing. It's actually not ever going to touch the x-axis. It's just going to constantly get closer and closer to it. It's not ever going to touch it. This is actually going to be a horizontal asymptote of this graph. But look at what this one looks like. So what happened between the first one that I graphed that looked like this, and then when the fraction, if it's a fraction that's less than 1 in front of the exponent, and the absolute value of it, not the symbol of it, just the absolute value of it, if the absolute value of it is less than 1, it's going to flip it across the y-axis, right? Isn't that what happened? If the original one looked like this, the first one that I did looked like that. Anytime that this number is a fraction that's less than 1, it's going to reflect it across the y-axis. Here is why. I can rewrite this in a different way. 1/3 to the x power is the same thing as saying +3 to the negative x power. And here's why. Remember, if you had me in transitional, remember what happens when your exponent is negative. In order to turn your exponent positive, you had to flip your base. So if I flipped this 3/1, because that's what 3 is 3/1. If I flipped it upside down, it would turn my exponent positive. Well, what do you get if you flip or you turn 3 upside down? You turns into 1/3, turns my exponent positive. So this is what is going to tell me later on when I'm doing my shifts. If your x and your exponent is negative, that is telling you that your exponential graph is going to reflect or flip across the y-axis. That's what makes that happen, is the exponent x being negative. Okay, so since these two things are the same thing, the exponent really is a negative x if you rewrote this. Okay, so that's why the same thing happens if this is a fraction less than 1, is meaning that this right here was a negative x in your exponent. That's what flips it across the y-axis, and we just proved it by plotting the points that we got from this function. Okay, so just keep that in mind for later on when we are doing some shifts. Okay, let's look at one like number 6 is not that much different. It just has an e in it, but remember, e is just another number. You have f of x equals 6/5 e to the x. Okay, so I am going to cheat and use my y equals on this one, just so I can make my table faster. Okay, so I go to my y equals, clear it out, open parentheses, 6/5, ooh, 6/5. Then remember where your E is. You'll hit your second button and then down here and hit that LN button. That'll give you your E. And look, it automatically puts your cursor up in the exponent. What is your exponent for this one? It's the x. That's where your x is. So let's graph this. See what it looks like. Is it going to be a regular exponential function or one that's flipped across the y-axis? This one's regular, right? Even though it has a fraction in front, 6/5 is greater than 1. And 6/5 times e is about 2.71. So this right here is going to be greater than 1. That's what makes it be a regular exponential function instead of flipped across the y-axis. So if I wanted to plot some of these points, again, I just go to second table. There's all the points in the world that you need. So let's see, -2 is 0.1624. -1 would be 0.44146. 0 is 1.2, so there's your y-intercept, which a lot of times that's this distinguishing feature that's gonna, if you're down to a couple of multiple choice problems that look really the same, that y-intercept is gonna be your distinguishing feature where it crosses through the y-axis. Let's see, 2, oh wait, I didn't do 1 yet. 1 is 3.2619. And we'll stop at 2. 2 is 8.8669. So if you plotted these, so let's plot some of these points. Let's see, -2, go up 0.1624. So left 2, up just a little bit. -1, up about a half. 0, 1.2, which means it's going to cross the y-axis just a little above 1. To the right 1, up 3.2, so 1, 2, 3, up a little above 3. And then to the right 2, up almost to 9. So again, it's a regular exponential shape on the graph from plotting those points. Okay, now I'm going to show you a couple of things about the shifts. The same thing shifts these exponential graphs that shifts all our other graphs. Remember how we shifted, some shifted left and right, some shifted up and down, and what makes that happen? Remember, a horizontal shift, the left and right shift, comes from inside numbers. So where are inside numbers when you're talking about these exponential graphs? The inside numbers are going to be up in the exponent. Okay, let's just say, just to show you where the inside and outside numbers would be. The inside numbers are going to be the numbers that are up in the exponent. And remember, what do we know about inside numbers? They shift you left and right, but you go opposite the sign. So this would shift you to the left 1. This is where you'll see your outside numbers. Okay, outside numbers shift you vertically or up and down, and you go with the sign, which means I would shift down 5 here. Okay, so let's look at a problem, and then I'm actually going to share my screen to show you something in Math Lab that you need to see to not drive yourself crazy on these graphs. So let's look at, actually, let's look at number 7 in Math Lab. So I'm going to share. Oh. Ah. Okay, Landra, do you see that I'm sharing problem number 7 and 9.3?
Yes.
Okay, good. Okay, so it says f of x equals 2 to the x minus 2. So what I have here is the base number is this 2. This minus 2 up in the exponent is going to be a horizontal shift because horizontal shifts are inside numbers and the inside numbers of exponents are the ones up in the exponent. So I'm going to go opposite the sign. So since it's minus 2, I'm actually going to shift right 2. Okay, so you'll come down here to the multiple choice, find the one that says 2 units to the right, which looks like D. So what you're going to put in here is the 2 for the base. So 2 to the X and shift the graph to the 2 units to the right. So now it's going to want me to graph this. So I'm going to click to enlarge the graph. Now you come over here to this toolbox, your palette. The exponential function, if you look at this one, if I hover over it, it'll say exponential tool. So that's the one you want to pick. And remember, just like when we did that transformation section, you can click anywhere on the graph. And that just puts your standard exponential looking graph. And then you have to tell it where you want to move it. So let's see, since I'm shifting it to the right 2, that's a horizontal shift. So I'll come down to the horizontal shift and go to the right 2. Now, here's why I wanted to share this screen. Look what it automatically has your base as down here in this little box. It has it set as E. The base of my graph is not E. The base number is this number, which is 2. So I need to change that E to a 2 before I can graph it. Now, watch when I click save. Watch this little yellow line. This is why it would drive you crazy if you didn't know that. Watch how little it changes from changing the base from an E to a 2. When I click save, watch how little that yellow line moves. Did you see before it went? It just barely moved it. So that's why I wanted to show you that you need to, when you go into Math Lab, make sure your base is the base that's in your problem, not E, okay? All right, I'm gonna stop sharing for a little bit and look at a problem like number 8. So that would be a horizontal shift. So let's look at problem like number 8 where the function is f of x equals 5 to the x minus 4. Whoops. 5 to the x and then minus 4. So on this one, right, this is an outside number this time. So that's a vertical shift up and down, but you go with the sign, which means you would tell your graph that you want to do a base of 5, an exponential graph, and you want to shift vertically down 4 is what you would need to tell it, okay? So again, you're going to have to tell it that you want your base to be, you're going to graph 5 to the x, and then you're going to shift it down 4 units, and then you'll graph it and tell it to do those things, and just make sure that the base that's down in that box is this number right here and not an E. Sometimes they just have it default set to E for some reason instead of what should be in the problem. Okay. Now I'm going to work number 9 on the board, and then I'm going to also work it also in Math Lab, and then I'll work 10 in Math Lab. Okay, you have f of x equals 2 to the 1 minus x plus 1. So several things happening here. the first thing I want to do on this one is actually rewrite my exponent with the x to come first. So if I do that, my base will stay 2. I'm just going to flip-flop this order. I like to see my x come before my constant, even when it's in an exponent. So if I do that, I'm going to have a negative x plus 1, and then my plus 1 on the outside. So several things are happening here. Remember early on when we were working the problem where I changed that 1/3 to the x was the same thing as saying 3 to the negative x. Those were the same thing. And what had happened with that graph? It shifted the regular exponential graph that usually looks like this to look like that. That happens because the exponent was a negative x. That's what's going to flip or reflect your graph across the y-axis, okay? Now, before we get into these that have reflections and shifts, there is a certain order that these things need to happen in to match the points that would be plotted if we did it by hand. So let's write those down. The order that these shifts and reflections would happen would be any kind of horizontal shift first. After a horizontal shift, you would look to see if there was any y-axis reflection. Then you would see if there's any x-axis reflection. And we'll talk about that in a second. And then you would see if there is any vertical shifts. Okay, so we know what makes the horizontal shift. Any kind of number that's inside or up in the exponent. This, since the exponent x is negative, that's going to reflect it across the y-axis. What's going to reflect it across the x-axis? The same thing that always reflects you across the x-axis. If your coefficient or your base number is negative, that is what would flip it across the x-axis. The base would still be 2. This would reflect you across the x-axis. This problem doesn't have it, but that's what would reflect you across the x. And then the vertical shift is the outside number. So that's the order that these shifts and reflections need to happen in order to match what would happen if you physically plotted each point and connected them to draw the graph. Okay? So let's see what would happen on this particular graph. So if you need to pause me to write that down, if you're watching later, then go ahead and pause and write that down because we're about to do these steps. Okay, so let's see. The first step would be any kind of horizontal shift. So let's see, I do have an inside number, which means I would shift to the left 1, since I go opposite that sign. Then I would look for a y-axis reflection. I do have that. Since the x up here is negative, I am going to reflect across the y. I'm not going to reflect across the x, right? Because this base number isn't negative. Do I have a vertical shift? An outside number gives me a vertical shift, so I'm going to shift up 1 because I go with that sign. So those are the things that would happen. Let's look at let's look at number 9. I'll share number 9. So this says 2 to the 1 minus x plus 3. So it's very similar to the one that I just did, right? Because it was 1 minus x plus 1. So I'm just going to change that to plus 3. which means all the same things are going to happen. I'm still going to shift it to the left 1. I'm still going to reflect it across the y-axis, but now I'm going to shift it up 3. So I have to actually graph it first and then tell it what I was going to do to graph it. So let's click on the graph, tell it you want to do an exponential tool, click anywhere on the graph. Now we're going to follow the right steps, the right order. We're going to do a horizontal shift first. So I'm going to shift to the left 1. Then I'm going to reflect it across the Y. So see, here's the 2 reflection things down here at the bottom of this box. So I'm going to reflect it, make sure you're checking the Y axis. And then I'm going to shift it up 3. So a vertical shift up 3. And if you'll notice while you're doing this, your little yellow exponential graph is moving, doing what you said. Now I do come check my base, but this one does have the correct base of +2. So I leave my base alone, click save, and then check your answer. Okay, then it's going to ask me, well, what did you just do to that graph? Okay, so let's see. They all are y equals 2 to the x. Let's see. I did shift left 1. Then I reflected it across the y, and then I shifted it up 3. So left 1, reflect across y, and then up 3. Okay, so let's do number 10 in the computer. F of x equals 4 minus 2 to the negative x. So write that down and let's see what all's happening here. Again, I want to rewrite this one again. And the only reason is this 4, I don't have to. I just like to see the base number, then the exponent, and then the outside numbers behind that. So let's see, if I'll rewrite that, I'll have -2 to the negative x, and then that's a +4. So several things are happening. I look for a horizontal shift first, which would be what? A number up in the exponent telling me to shift it left or right, but I don't have any of those, right? There are no numbers up in the exponent to shift me. So there's no horizontal shift. After that, the second step is you look for a reflection across the y-axis, and what makes that happen? Your exponent x being negative. So yes, there is a reflect across y. Then you would look for a reflect across x. Here's what makes that happen on this one. This 2 being negative, that's going to reflect you across the x. So there is an x-axis reflection on this one. And the last thing you're always looking for is a vertical shift, which is an up or down shift, and that comes from your outside number. So since this one does have that, you go with the sign. So I am going to shift up 4. So that's what you need to tell your graph. Which one says to reflect across y, then across x, and then shift up 4. So across y, then x, up 4. Oh, what do I need to put in there? What is my base? And this is important. Your base is just the 2. The negative is what gave it the x-axis reflection. So your base is just 2. And then graph it. So again, tell it you want the exponential. Click anywhere. There is no horizontal shift, so I skip that. I do reflect across the y, then across the x. Oh, what happened? Oh, I'm gonna start over. I don't know what happened there. So no horizontal shift. Reflect across y, then x, there is a vertical shift, right? I need to go up 4, so up to the positive 4. And look again, they're tricky. They made your base be E. What does my base need to be? My base needs to be 2. And then save it, and then check it. Okay? All right, so there's nothing else new with that. All the shifts are just what we have learned before with the outside and inside numbers. The only thing new is the y-axis reflection. So now what we're going to talk about, I'm going to stop sharing, is a formula that goes with investing your money. And it has to do with exponential functions. So this formula is A equals P, open parentheses, 1 plus R over M to the NT. So now let's talk about what all these letters mean. Okay? A is going to be the amount of money you have at the end. The P is what's called your principal. The principal is the amount of money that you invest on the front end. That's the amount of money you put into the account. Let's see, what else do we have? We've got an R. R is your interest rate. And it's your interest rate in decimal form. Let's see what else we have. We have an N. N is maybe something new. This is going to be how often a year the money is what's called compounded or reinvested. So that's the number of times compounded. And T, the last thing, is going to be the number, the time, the number of years that your money was invested. Okay, so I'll let you write that down real quick. And let's work a couple of problems using this formula. Again, A is the amount of money that you're going to end up with. P is the principal. That's the amount of money that you're going to invest on the front end. R is your interest rate, and it's going to need to be written in decimal form, not percentage form. N is the number of time your money is compounded, and then T is the number of years your money is invested. So I'm going to leave the formula up there, but erase the rest of this, so we'll have spot to work these problems. Okay, so let's say, suppose that $87,000 is invested at 5.5% interest. It's compounded quarterly. Find the function for the amount to which the investment grows after T years. So we're not going to know the number of years yet. We're just going to come up with this formula that we're going to be able to use, and then we can plug in our own amount of years to see how much money we would have after a certain number of years. So let's see, what is our principal? That is the amount of money that was invested, which was $87,000. It was invested at 5% interest. So let's think about this. The interest, oh wait, not 5.5%. So this is how it's written. So let's think about what does 1/2 mean? That means 5.5%. but it doesn't want it in percentage form. It wants it in decimal form, which means I need to move this decimal 2 places to the left. So when I enter this into the formula, I'm going to enter it as 0.055. Let's see, the number of times compounded. So this said it was compounded quarterly, which means it was compounded 4 times a year. That's what that number means. If you're quarterly, that's once 4 times. So the compound number is 4. We don't know the t. We're going to keep that t as part of the formula in the first part of this problem. So let's see what this would look like. A equals, what are you going to put in place of the principal? 87,000. Open parentheses, there's your 1. Plus, what are you going to put as your rate? Remember, it needs to be in the decimal form. So 0.055 over, what is your n? Your n is 4. Close your parentheses. Now, your n again is 4. You don't know what t is. So when you enter this in as the first part of your answer, it's going to ask you for the formula as the first part of the question. It doesn't want to see all of this mess in here. It wants to see this just as one number. You can just go straight to your calculator, to your home screen, and just type in 1 plus 0.055 over 4. That's all you got to do. So 1 plus 0.055 over 4. Oh, I got too many decimals. 1 plus 0.055 over 4. So that's what it's going to want inside that parentheses, 1.01375. So that's going to be your formula that you're going to use for the rest of this problem. So you have 87,000, open parentheses, 1.01375 to the 4t. Okay? So that's going to be the first answer to the first part of the problem. So I'm going to rewrite this up here. I'm going to erase all this and rewrite the formula that we're going to use for the rest of the answers. So let's see, I had 87,000 times 1.01375 to the 4t was the formula that we needed to use for the rest of this problem. Because now it's going to ask you, how much money do you have after 0 years? So where am I going to put that 0? That's the years. So I'll put it here. So I'm going to have 87,000 times 1.01375. What do you get if you put a 0 in this t spot? You have 4 times 0, which is 0. If you put that in your calculator, it's just going to give you $87,000. Why is that? Well, if you put in $87,000 and you haven't left it in there any amount of time, they're not automatically just going to give you more money, right? It hasn't been invested in any time, okay? So, and also think about this. What is anything to the 0 power equal to? It's equal to 1. So this all right here, 1.01375 to the 0 power is just 1. So this really just says 87,000 times 1, which is 87,000. Now, look what happens going through more years. Let's say it's been in there 3 years. So where do we put this 3? It goes in this spot right here for the t. So you'll have 4 times 3, which gives you what as your exponent? A 12. Let's type this into our calculator and see what this gives me. So I'm going to have 87,000. Oh my gosh, what's wrong with me? I got to do it like this. Open parentheses, 1.01375, close. Then go up in your exponent, and then make your exponent be 12. And hit enter. That's how much money you would have after 3 years. If you invested $87,000 at 5.5% interest rate and it was compounded quarterly, after 3 years, you would have $102,491.92. So then I need to think, oh, what does this want me to do? It wants me to round it to the nearest dollar. So what does this 9 round this up to? So this needs to be 92 at the end there. Okay. What if you left it in for 10 years? What's changing every time? Just this t is, right? The number of years is changing, which means the t is changing. And if I've had it in there 10 years, then my exponent will change to 40. So let's see how much money you will have in after 10 years. So again, you're just typing in 87,000, open parentheses, 1.01375, close. This time your exponent needs to be 40. So that's how much money you would have after 10 years. Again, round it to the nearest dollar, which means I look after the decimal, and since it's a 0, I don't need to round up that 9. Okay, let's work another one of these problems using the same formula. Okay, so let's say on Melissa's 6th birthday, she gets a $5,000 CD that earns 6% interest, compounded semi-annually. If the CD matures on her 11th birthday, how much money will be available? So let's see. We know the principal. How much money did she get? How much money is she going to invest on the front end? She's going to invest, she got a $5,000 CD. So the principal is $5,000. The interest rate, it says, was 6%. So if the interest rate is 6% and I move my decimal 2 places to the left to turn it into a decimal, I will have 0.06. Let's see, I also know the number of times it is compounded. This time it says it was compounded semi-annually. That means it's compounded semi-annually, means twice a year. So the compound number is 2. Now, it says if the CD matures on her 11th birthday, she got it on her 6th birthday, it's going to mature on her 11th birthday. How long has she had it in the account? How long has it been invested? 5 years, right? She got it on her 6th birthday, and it matures on her 11th. That means your T is going to be 5 years. So let's see how much money I'm going to have at the end. If I use the formula with these numbers, your principal is 5,000. 1 plus, your rate is 0.06 over the number of times it's compounded, which is 2. Number of times it's compounded again is 2 times the number of years. This time I do know it's been in there. It's been invested 5 years. So let's see what's inside here. What's that going to be? I have 1 plus 0.06 over 2, which gives me 1.03. So I have 5,000 times 1.03. What's my exponent going to be? I have 2 times 5, so it's going to be 10. So let's just see what that gives me. Type that in your calculator. 5,000, open parentheses, 1.03, close. Go up into your exponent and make your exponent a 10. Hit enter. After 5 years, she has this amount of money, and you need to round it to the nearest cent. So there's my nearest cent. If I go after the 8, it's a 1, which means I don't need to round it up. So on her 11th birthday, she'll have $6,719.58. Okay. If you have any questions, shoot me an email. Have a good weekend. Remember, you've got test review, test number 3, and 9.3 due on Sunday, November 8th at midnight. Have a great weekend.